Today will be about the movement that we ended with last time, logical positivism. Okay, so this will be the school that we will be talking about today. This is a very influential movement in the dawn of the 20th century. And so this comes from Auguste Comte, the founder, let's say the godfather of sociology, who initially called his science, by the way, the physics or social physics or something along these lines. So the physics of society. So he kind of believed that we could access those truths about society in the same way that physics is systematic. And he devised the stages of evolution of the human history, let's say, or human civilization into three big stages. You had the metaphysical stage, you had the theological stage, which are two early stages where people either depended on other people, other clergy, or on metaphysical explanations, any god, anything they can imagine. Whereas the positivist stage for him happened quite around or after the French Revolution, where people kind of believed that they can own their own truth, they can access it, they can act upon it, politically, socially, etc., and all of that, because he was a sociologist. That's what he's interested in. But that word gained that meaning, that feeling of positive action and certainty, and so they borrowed it. Those logical positivists, they borrowed the term to their own benefit, and combined with the school of logic that was developing in parallel in mathematics. On slide 4, you will see the slide that also we saw. Logical positivism, how does it happen? It takes the logic from the mathematical logic, as the only reliable mental tool. Your emotions, your impressions, your feelings, that's not meaningful for them. You really need to be thinking clearly. Bertrand Russell makes a huge deal about clear thinking, he calls it. And the positive from Auguste Comte's last stage, where it's ruled by empirical observation as the only reliable tool for generating knowledge. Not metaphysics, not people telling you what to do, your leaders, your whatever. No, you can go experience the world yourself and get the knowledge yourself. And so this school is against, of course, idealism and spiritualism, etc. We will talk about that. So on slide 5 is the opposite camp. And I should explain what the opposite camp was doing before logical positivism was born. There was this school of German idealists in the beginning of the 19th century. Kant's ideas were picking up again. People picked them up again after a couple of hundred years where he was known, but it really picked up again during that period. And they started evolving as well. So people picked up the analytic synthetic, people picked up these things, and they said, oh wow, there's something there. Not quite as Kant said. So they are called the Neo-Kantians. And there was a sister school called Idealism. And this school, Idealism, is also very, very old. Idealism basically is a spiritual belief more than it is a philosophy. I don't know what the real boundary between the two is, but if you think of all the Eastern religions, Western religions kind of started becoming more and more, especially after Aquinas and all that, it kind of started moving a little bit towards some more systematic thinking, but it still was idealist nonetheless. It's the belief that there is a big mind, a big consciousness, a big meaning out there somewhere in the universe. And they had no problem talking about these entities that are not tangible. So, for example, Leibniz, the same Leibniz who worked on calculus, he had this theory about monads. And monads are these, for him, he just called those individual bits of consciousness. He called them monads, like small units of consciousness, small units of experience, okay? And these monads can be aware of each other, they can interact. He had this whole system going on. Kant, then he had his transcendental idealism. There are definitions on the chat. If you just hover over with your mouse or with your thingy, you can access small reminders if you forget what these are. I don't want to really dwell on this. It's not my topic for today. Hegel also, he was speaking about zeitgeist Zeitgeist, Zeit in German means time, and Geist is like spirit. So Hegel was like looking at history as if the universe had a certain consciousness, a certain will. It's a collective consciousness, not a collection of separate consciousness, like, for example, for Leibniz. No. He saw it as like a one consciousness, and then it had bits and pieces here and there. And so the universe for him was kind of being aware of itself through the human beings. We are kind of the brain of this big being, this oneness that is the universe. I'm trying not to be, I'm trying to do my best here to do Hegel. Hegel is notoriously difficult to read. Not that the others are a lot easier, but Hegel is notoriously difficult to read. And we will go back to this point on Hegel's difficulty in a minute. If you've ever listened to Neil deGrasse Tyson speak, he is sort of a Hegelian somewhere. Oh, we are the stars, we are the universe, the stars are in us, we are one with the universe. All that stuff, all that kind of talk, this is very much like idealist speech. So this is the rival school. Logical positivism was born as a reaction to this. Right after the First World War, all the cards were mixed. And this group of mostly German physicists, and this is an important point we'll go back to, because Hegel also is German. So they were living in the moment, in the space where those ideas were developing. Also remember that Karl Marx was Hegel's student. So after the First World War and after the revolution in Russia and after all these events, those ideas were very much alive and very popular. People were reading Hegel as a standard reading at the time. And so these physicists, these scientists, some of them are mathematicians, some of them are philosophers, but they are very well versed in the scientific method and in the mathematics, etc. They started coming together, and they were fed up with this romanticism and this idealism business. They were so fed up with it. And they started meeting at the University of Vienna under the leadership of Moritz Schlick. Moritz Schlick is a physicist. Kurt Gödel also regularly attended these meetings, among others, and this started becoming being called as the Vienna Circle. So this group of physicists that sit in the University of Vienna, and they started discussing philosophy of science, how to get rid of this idealism business, etc. A sister movement also started in Berlin, also in the German sphere, under Hans Reichenbach, Karl Hampel. We've seen Karl Hampel. Do you remember where we've seen Karl Hampel before this name? Hampel's induction problem. We've seen it when we did the induction episode, when we explained the induction problem of Hume, and then we said, oh, it gets worse, and then Hampel had a modification on it. If you haven't seen the episode, highly recommended. It's already on YouTube. You can go check it out. So we know these names. David Hilbert, famous mathematician also. And also occasionally Albert Einstein, because he was living in Berlin at the time. He occasionally attended as well. So it was a collection of the biggest minds in the scientific field at the time. The two circles, as they sent people to visit each other and exchange letters, etc., that movement for the next 20 to 30 years is called logical positivism. It's a collection of scientists and scientifically literate people, very nerdy mathematicians, who sat down and said, enough crap, we're going to do it the proper way. And of course, we know what the proper way looks like. We already got a taste of it. The proper way is, let's get rid of all that nonsense of idealism. So the aim for science for those people is that every scientist, these are on slide 7, the words of Moritz Schlick himself. What every scientist seeks, and seeks alone, are the rules which govern the connection of experiences by which alone they can be predicted. We observe, we make guesses, we are wrong, we can be wrong, and this is important because people were accusing the logical positivists that they believe that science is perfect, etc. No, they were just hardcore. It's not that they believed that they are 100% correct and they were having a small religion around science. That's not the case. You can be wrong and then you try again. That's what science is about, and that's what every person should be aiming for. This belief of spiritualism and romanticism and all that stuff they did not really like. He believed also in the movement kind of produced, I think it was Neurath who kind of started the unity of science thingy. They also believe that you need to reconcile all the different schools of science, chemistry, biology, physics, philosophy. They need to come together so that they can create new knowledge faster. It's not that the reality is divided. No. The real universe is one, and we can describe it. We can work on untangling its mysteries together. All the domains are a single epistemic entity. There is no division. It's artificial. Of course, number two, we spoke about logicism. Again, one more time, it's the only reliable mental tool. Relying on your intuition, on your faith, on your, oh, it's my point of view, it's kind of what I like. It's just against everything that they stand for. And of course, positivism, again, it is this emphasis that we can access knowledge by applying logic and analysis directly onto the empirical input that we have received. I will move on to this to more points. Number four, this is a new idea. This is a distinction between two families of entities in the scientific theory. There is observational language and there is theoretical language. Moritz Schlick, he thought that these terms only refer to sensations are observational. Initially, that's how the idea was born. So anything that your five senses can immediately touch, they can immediately interact with, that is what observation is, and everything else in the theory is theoretical. That's what's meaningful. I want to touch it. Can I touch it? Yes. That it's observational. I can. Theoretical, yeah, we see whether you need it or not. We did another room about the indispensability argument. Whether we really need those theoretical entities or not, and how do we decide? The problem with that, they realized it very quickly. So the example is on slide 8. The metal rod is glowing red. So if you have a metal rod in front of you and you heat it up, it's glowing red. If you say the metal rod is glowing red, that is very observational. You can immediately touch it. You can immediately see it with your five senses. Whereas if I say the atoms of the metal rod are radiating energy now, this is not observational anymore, because you cannot touch or see with your bare eyes, with your immediate senses, the atoms and the energy and all those entities that I have invoked. And so Neurath, the same guy who did the unification thingy, he believed that this public access should be very important. You cannot rely on personal experience, whether you see it or not, whether the scientist sees it or not. This is not proper. So he said, "Oh no, we're gonna remove that. We're gonna make it a little bit more general. We're gonna say that now observational language is something that is observable using scientific testing methods that anybody can use. So anything that science discovers, anything that you can detect with an experiment, this is now an observational entity. You don't really have to do the experiment also. So when I say, oh, the backside of the moon, I don't have to go and then take a spaceship and then land on the dark side of the moon. I can speak about it because I know that there is a possible experiment that can reveal this truth to me in an observational way. How do I access the backside of the moon? I take the rocket, go there. It's going to cost me. It's going to be very expensive. It's going to take cancer, but we can do it. If we can do it, then it is observational. We're allowed to admit that it is observable. Whereas the ones that we cannot observe at all remain in the theoretical bit. So anything that has to do with mathematics, anything that has to do with, let's say, energy, center of gravity, those terms you cannot really interact with at all in an experiment. You just have to look for their entailments. You have to look for their behavior and say, oh, this is where energy was transferred because 1, 2, 3 happened. If that is the case, this is a theoretical entity, not an observational entity. Is the distinction clear between these two?
Yeah, I mean, I always bring up, and I think I've really gotten very comfortable with this idea that the entire aim of science is to be able to tell you, to predict in advance that the needle on some meter will point to 2. Right? Anything beyond that, what the meter is reading, what the 2 means, that's all theoretical.
So you are for logical positivism so far. You're enjoying it.
I think so. Yeah.
Great, cool. It'll get better then, I promise. We're gonna get even better now. Slide 9. They introduce one more thing as well. This is the verifiability theory. They're gonna tell us now, after they divided the language into observational and theoretical, they're gonna tell us now what is it that we should be talking about, what's meaningful for the scientific community and what's not meaningful. Now they're gonna tell us, those logical positivists, what is it that we are allowed to talk about meaningfully and what is it that is not meaningful for them. Because that was the whole agenda, remember. In the beginning, they set out to cancel those very weird entities of zeitgeist and all that stuff. So now, they say the following. A meaningful claim is a theoretically testable claim. A meaningful claim is a theoretically testable claim. If a sentence, after we write it and read it, whether it is true or false, changes nothing in the observational data that we have, changes nothing in the states of affairs of the universe they have. If the universe looks the same whether the sentence is true or false, the sentence is meaningless. It is empty. Maurice Schlick writes, a proposition for which the world looks the same whether true or false is empty. It's meaningless. You need to tell me what this sentence actually changes in the world. What entities of the world does it invoke? Oh, the spirit of the world is, realizing itself. All that, it's nonsense for them. Poetic, emotional, traditional philosophy, ethics, theology, all of those, they fail this test, this verifiability test. History, sociology, psychology, etc. Those were seen as empirical sciences, empirical studies, but they were irrelevant to the exercise of, quote unquote, this is also a direct quote, logically analyzing about science. That's what the logical positivists thought they were doing. They were logically and carefully analyzing science. They weren't doing philosophy of science. Because philosophy is bad, remember? It talks about very vague and then all over and above the physical universe entities, whereas they are grounded in empiria. They are grounded in the physical world. Whatever is meaningful for them has to have visible and detectable and observable entailments on the real world. Don't talk to me about all that nonsense. On slide 10, I took a snapshot of Hans Reichenbach, The Rise of Scientific Philosophy. This is the very first page. If you read with me on slide 10, he says, here's a passage taken from the writings of a famous philosopher. It doesn't even name him. He's talking about Hegel, of course. And remember, I told you that Hegel is notoriously difficult to understand and to learn. And this is exactly what Reichenbach is lamenting. So I'm not going to read the whole thing. I'm just going to read the quote of Hegel. Hegel says, reason, or the translation actually says, reason is substance, as well as infinite power, its own infinite material underlying all the natural and spiritual life, as also the infinite form, that which sets the material in motion. Reason is the substance from which all things derive their being. End quote. And then Reichenbach goes on in the passage, very funny, take a minute to read it on your own time. He goes on to lament the fact that if you are a student first year's philosophy studying, or philology studying, or even philosophy of science, even you look at this and you say, I'm so stupid. I can't understand this. Hegel is such a genius. This sounds so complicated for me to understand. And then you spend all your life in the philosophy department, and then until you give up, you just say, oh, you just learn to repeat exactly what Hegel said in different words so that you sound that you understood Hegel. Reichenbach said, nobody understands what this man means. First year students philosophy, do not blame yourselves. This man is talking nonsense. And then he goes on to prove that he's talking nonsense, establishing all that we're talking about with the verifiability and then what the empirical entailments of this. You look at this sentence and there's nothing tangible about it. Still, it is considered to be a very fundamental, very important philosophical text. Okay, so this is the main idea of the verifiability theory of meaning. Now the question is, well, we are removing all of these meaningless statements because they have nothing to do with empiria, right? What about mathematics? Mathematics, we said, has nothing to do with empiria. It has nothing to do with the physical universe. It's not physical. You do it because it makes sense. It's a game that you play on the paper. It has nothing to do with it. What about it? But then at the same time, it's reflected on the physical universe. It has entailments. It works very wonderfully. We did a whole room about the nature of mathematics. It's also on YouTube. I'm glad that now we have all of these topics already done, so that I can move on, because if people have attended frequently, they know exactly what I'm talking about. So on slide 11, you will find the answer that they provide. The logical positivists, they saw the Kantian ideas, and then they saw the other camp, the Neo-Kantians, using those words. And they said, okay, you know what, it looks fine. This distinction looks like it makes sense. However, the thing that they had a problem with is this synthetic a priori business that John was annoyed by. Well, they were annoyed as well. Instead, they have a very simple outlook. You have two kinds of statements: analytic, and those are the statements which truth value does not depend on the state of affairs in the world. So they are known a priori. Okay? Complete marriage between a priori and analytic now. And synthetic statements, they do express something about the physical world. And as you express something about the physical world, they can be true or false. And as they can be true or false, we can understand them because we can see when they are true or false, because they are observable. And this makes them synthetic. They tell us something new. A posteriori, we discovered it. Very simple outlook. And what about mathematics here? Mathematics is broken into two pieces. There is the piece that has no application at all, which remains theoretical, remains analytical, pure deduction. Whereas there's another piece that is used in science, in math, in chemistry, in physics, etc. Math is used in math, in chemistry and physics, I mean to say. And this is synthetic. Mathematics has two pieces: a piece that is analytic, pure reason; a piece that is synthetic, has to do with the physical universe. It is a posteriori. No reason to take mathematics as a package and then invent new places for that package to exist and new fixes for the theory that's already broken, as we will discover. No. Just take the stuff that you need for the science, and then this has some nature, and then the other pieces that you want to play with, go play with on your own time. This is the position about mathematics for the logical positivist.
Well, so I don't know, I only have kind of vague thoughts along the lines of the important thing for me being the distinction between the world of a model, which is entirely the product of the human mind, general relativity, the idea of space-time being curved by concentrations of mass and energy. This is not a statement about the real world. I can tell you things and I can prove those things because it's couched in the language of mathematics. I can prove things. Absolutely. Those things are a priori, I would say, true. Everything I can prove about general relativity is a priori true, at least given the fundamental postulates of the theory, the language within which it's couched, has nothing whatsoever to do with the real world. But the job of science is to build things like that. I could build any kind of model I wanted, and I could prove things about that model. But unless it maps onto the real world in the form of making predictions about observations, what number this meter needle will point to, it's not useful for science, and that's really the only difference. And ultimately, we're simply not talking. Science doesn't talk about the real world. It just checks with the real world to see what its models, whether its models are mapping onto it well or not.
Well, if you're checking with the physical world constantly, why would you not be talking about the
Well,
world?
I mean, I guess I'm overstating the case, but I think the point is that everything that science, everything that theoretical physicists do has nothing to do innately with the real world, other than the fact that they're taking real world observations, and their game is to build a model that that post-dicts all those observations and predicts other observations that we just haven't made yet that we can use to test the model. Test the model in the sense of just seeing whether this model maps onto the real world well or not. We could equally well play that game with any model we want, but scientists just aren't interested in those. There's no difference between a model that doesn't map onto the real world and one that does, other than the fact that it does and the other one doesn't.
That's basic enough. Tell you what, Rudolf Carnap agrees with you, as we will see on slide 12. He writes, we believed that, as a movement, the rationalists, talking about the rational camp that we mentioned in the beginning, they had been right in rejecting the old empiricist view that the truth of 2 + 2 is 4 is contingent on the observation of facts. You know, there's this idea in the old empirical camp that math is kind of inspired and a reflection of the real world. A view that would lead to the unacceptable, I have it highlighted in yellow, unacceptable consequence that an arithmetic statement might be possibly refuted tomorrow by new experiments, new experiences. They have nothing to do with the real world. Those models we toy with have nothing to do with the real world, except, as John said, when they do. So our solution as a movement consists in asserting the thesis of empiricism only for factual truths, those that have to do with the real world. By contrast, the truths of logic and mathematics are not in need for confirmation by observation, because they do not state anything about the world of facts. They hold for any possible combination of facts, no matter what the state of affairs in the universe is. As John reiterated now, Carnap agrees. You have the axioms, you have the derivation rules, you have a nice mind that can work it out. Go ahead, you don't need anything. Okay, so this distinction of synthetic, analytic, and all of that boiled down to these two categories, which is even more good news for us. As it becomes simpler and simpler, this is better and easier to understand and easier to apply. You know, the old system kind of was very freaky. What do you mean synthetic a priori? And then I don't know what that is. But for the logical positivists, are you talking about the system or are you talking about the world? That's it. That's all they want to know. On slide 13, I threw some links to other topics I'm going to cover. People who were allies of the movement but were not particularly attending meetings include the famous Ludwig Wittgenstein. And we need to do a room about Ludwig Wittgenstein, although I would hate to do it myself, because I find him also notoriously difficult to understand. But Ludwig Wittgenstein was very influential, as he laid down those views of philosophy of language that allowed those logical positivists to go where they want to go. I want to draw your attention to one thing, though. Notice that as I'm talking about science, I'm talking about physics. We're trying to fix the theory of science. We cannot escape talking about the theory of meaning, the theory of language. We cannot escape it. These things are tied together. I cannot fix my science without fixing my philosophy. I cannot fix my philosophy without fixing my logic. I cannot fix my philosophy and my logic without fixing my theory of meaning. I need to know what those things are before I start working on individual studies of individual experiments in science. So for all those people who were a little bit scared of doing this exercise of philosophy, including the logical positivists themselves, they did not realize that they are already too deep. And we're going to go back to that idea at the end, as we tell the story of the evolution and the failure of this school. So Ludwig Wittgenstein was an important figure. Heinz Reichenbach, I already mentioned him, also an important figure. Probably we should do another room on Heinz Reichenbach, especially about his common cause principle that I mentioned a couple of times in past rooms. This is an important idea. Also Percy Bridgman, who's also a physicist, with his idea of operationalism. It's a kind of a tightening up of this verification thing. Very quickly, operationalism says if you want to understand the meaning of words in your theory of science, you need to give me physical recipes to do what you need me to do. It's exactly like cooking. What is pasta? Pasta is this recipe. Go do it. What is weight? What is charge? What is whatever? This is how we know. You need to give me the physical recipe of how I can access this. Very, very shortly. We're going to do another big room because this has many ramifications. I chose not to go into it today so that we can give it its own space. Those logical positivists, they were liberals, they were rebels. They had this, they were very well educated for their time, very well, extremely well educated relative to their peers. And so they clashed politically with the rise of the Nazi Party. They were mostly in Germany and in Vienna, and this is the influence of that nationalist camp. And some of them also were Jewish, so that even made it worse. They were persecuted as the Nazi Party took more and more control, and they mostly fled to the UK and the US, where their ideas kept evolving and they kind of shifted. We will see the shift towards as we continue the presentation. Moritz Schlick was assassinated, and that was the beginning of that realization that we need to move away. Some of them started leaving before, but after Moritz Schlick was killed, they realized there was no way that they can stay in Vienna and Berlin. Although, as I read the story, I wanted to figure out there are conflicting stories. Some say that he was assassinated for political reasons, although he wasn't Jewish himself. But the stories of the trial say that the guy who committed the crime, he turned the tribunal to a rally. So the courtroom was very heated in political debate. Others say that the reason was completely irrelevant. Moritz Schlick was involved with his female student who was involved with this guy, and so it's a problem of jealousy. Whatever the reason is, Moritz Schlick assassination ended the whole thing, and then people had to massively leave the German space, let's call it, towards the UK and the US. As many of you paid attention, this principle of getting into, as we saw now points in chat, getting into the language, it was a misstep. It was too quick, okay, and it was too simple for it to work. The main problem, the number one problem, is how do we formulate exactly this principle of verificationism? How is it that we write it so that it includes exactly what we want and disregards exactly what we want to disregard? Schlick writes it in the following way. On slide 14, you will see a proposition for which the world looks the same, whether true or false, is empty. This is what we said a minute ago. It's very easily refuted. It's very easily toyed with. For example, metals expand whenever they are heated. That's a very verifiable statement. Versus the spirit of metals is vulnerable to chi. And then as the chi changes, they expand whenever they are heated. As I included these funny, weird words in the sentence, it still bears the same exact consequences on the physical universe. Someone who believes in spirit, as I used it, and someone who doesn't, cannot tell the difference just by experience, which destroys this division that they had in mind. Again, the intention is very clear, it's very honest, it's very understandable. But as you formulate it in that way, it allows for everything you want to disallow. Just include whatever words you want, as long as you include the part that is observable and verifiable, according to the logical positivist, and you're fine. That's all you need. As long as you include, for example, for Schlick, the part that makes the word look differently, as long as you include it in your sentence and then include some more things, no problem. How is it verifiable? As you read the sentence, you can tell whether metals expand or not. It's very verifiable still, very observable. But all those other entities in the language were not. And so again, the logical positivists paid attention to this. And Karl Popper, who came in, he picked up on this error. Karl Popper wasn't an ally. He was kind of was kind of alone in between, attacking the logical positivists and then creating his own view. We're going to have a room also about Popper, because there are big fans of Karl Popper among our friends. He says the scientific hypothesis fails the criterion. Anytime the scientists proposes a hypothesis, anytime the scientist says, oh, it could be the case that 1, 2, 3, cannot be verified according to the logical positivist criteria, according to Marshall. Why? Because as you attempt to verify it, if you know what's going to happen, if you discover during the verification what's going to happen, then you have discovered the quote-unquote meaning of the sentence. You have discovered what change it induces in the world. And if you already know what changes it induces in the world, it's not a hypothesis anymore. It's either a theorem or not a theorem. It's a law of nature or not a law of nature. You know, but it was a hypothesis. By construction, we don't know. And so anything that is on the edge of scientific discovery fails that criterion. So we can only do science with whatever that is established and accepted. And then here you ask the other question, which he asked, but we're not going to go in here today. How is it that we established it to begin with? And what is the criterion for saying, oh, now this is scientific knowledge and the other ones are not? So the Karl Popper is most famous for his answer to this problem, namely the demarcation, we call it, and his falsification criteria. Also, he paid attention to another fact: the content of the verifiability criterion itself. That statement that Morris Schlick and others kind of adapted, and there are changes. I'm going to include them in a minute. But every statement, every definition of this. So if you think, oh, let's make another definition, and people have tried, but every other definition also fails this verifiability criterion. It cannot be empirically tested itself. And so it's kind of self-refuting. So this adds pressure to this division of verifiability. We want to remove all those entities from the theory that are not verifiable, that are not empirically important, that are not empirically testable. Well, you end up allowing a lot of things in, like center of gravity, personality, as sociologists and psychologists talk about personality. What's personality? It's not something physical, but you can perceive its changes in the real world. You can know what we're talking about as you test it. We have tests for these things now that more or less measure certain traits, at least. And so it doesn't have to exist in the world, but I can see its entailments. I can see if it is this or that, what is changes in the world. So all of these things that they wanted to remove, they kind of slip in. And so it failed. It did not work, and we will see a modification of it in a minute. Still, as we see Karl Popper here, he kind of puts the nails in the coffin. We cannot work without scientific hypotheses, and at the same time, whatever definition you come up with is gonna not include itself. It will just refute itself as not verifiable. Any question on this first point? So on slides 14 and 15. Problem number 2 is the analytic synthetic distinction, which we have said many times, and rightly so. Wissam also in chat pointed out this also was a massive misstep. You picked up on Kant. Kant is already 300 years old. Dude, come on. This cannot be a good idea. But for the following reason. So the star here is Quine. And Quine is also kind of a second generation person here. He was kind of sometimes in the early stages, he kind of was influenced by the movement, but then he quickly got out, and he became the main enemy. He became the main criticizer of the logical positivist school. About analytic synthetic, he says the following: all claims should be revisable, including analytic ones. John, I'm sorry, if you like Carnap, Quine is against you. You cannot have non-revisable analytic claims in your theory. What are you talking about? Analytic truth given by logic cannot be refuted by empirical evidence, and so what? It stays forever. That's not how science works. If I have an axiom that is working sometimes, so I was happy with it until I discovered it's not working, I should take that axiom, throw it away, or change it, or replace it with something, or do something. You cannot have an analytic truth that stays there forever. And I'm only saying this But that statement of no analytic truths is actually deeper. It starts with Quine and goes very deep. If you recall, when I did the room on the nature of mathematics, and I said there's this formalist school of math, and then the meaning of mathematics is nothing. Mathematics is meaningless for them. And can we access mathematics and be sure of it? Absolutely no. We said that because the way mathematics work, the whole community of mathematicians decides what works and what doesn't work. That's how it works with physics, with math, with everything. And so this eternally true, it cannot be refuted by experiment, etc., is not the case when it comes to science, at least. If you want to play with a mathematical theory on the piece of paper, and you don't want to ontologically commit, like I personally do, that these are also physical entities, then you can. But if you're talking about philosophy of science, for Quine, this is a red line. Be careful, you cannot be dogmatic. In fact, he wrote the paper, the two dogmas of empiricism. That was the name of his main work, his main paper. And so he thinks that this analytic synthetic thing is a dogma and we need to get rid of it. That's his point. Analytic statements are also not verifiable because they are analytic. How can they have bearing on the real world? And then they depend on what? They depend on convention, as we just said. So if something depends on your convention, you want to keep it in your theory, and then the things that is very empirical and very observable, you want to change it? What does convention have to do with the physical world? If you're trying to build a scientific theory, you better not rely on our convention and our tools and our presuppositions about it. No, you better rely on the actual empirical thing. You're going to seriously allow change in the empirical business, but then the theoretical business, you want to keep it fixed. That's weird. And after I say it now, it's yeah, of course, that's obvious. It slipped. I'm oversimplifying, of course, but you get the point. Number 3, the meaning of the claim by verification. And this is an important one. As I take a claim and I want to verify it according to the positivists to see its entailments in the real world, and how the real world would look like if this was true or false, to understand what the claim is about. As I try to apply this depends on the entire body of the theory. Not only on the contents of that claim, on the entire body of the theoretical and the observational. The whole thing will participate in understanding that one claim, not the individual words in it. This view has become to be called holism. Scientific holism is understanding the scientific theory as one. It's a whole body of claims, not individual sentences that are acting alone. To give you an example to see what we're talking about. I'll use John's example, actually. The aim of science, forgive me for paraphrasing here, is to predict what the meter would read. So you have a voltmeter, you have a whatever meter, humidity meter. The aim of a scientific theory is to help you predict and understand and entangle that. Okay? When I say the meter is reading 3, whatever unit, that sentence, the meaning of it, cannot be only contained in the sentence, because then I got to ask you what a meter is. What kind of amp meter or voltmeter or whatever, what is it? And then as you explain to me what this voltmeter is, you're going to use new words. Oh, this voltmeter is this machine that kind of receives the current, and then the current does this with the electromagnetic blah, blah, blah. And then as the needle moves, you read this value, and this value indicates this. And then I have more questions. I'm going to ask you, well, wow, how is it that what is it that you talk about? There's an electric current somewhere. This is what you, and then it goes through the loop, and then it creates a magnetic field. What are you talking about? And then you start explaining current, and you start explaining magnetic field for me and how they are induced, and then Maxwell's equations, and you start telling the whole entire story. You take the whole electromagnetism with you, and particle physics on top of it, and probably relativity if you want to be very precise. You will take the entire body of physical theory if you want to understand that claim precisely, to see if it's verifiable or not. You cannot take one statement and then say, oh, I understand the meaning. You only understand the meaning because, first of all, as Wittgenstein will remind us, you think you understand. You can never really know. But assuming you do, okay, you only understand it, you only have access to it because you already have a full body of scientific knowledge in your pocket. We're not doing this. We're trying to question the scientific theory, I thought. We're not a religion. We are moving away from this idealism, blah, blah, blah. We want to be able to know exactly where this meaning is coming from. It's coming from the entire body of the theory, the observational and the theoretical, all together. You cannot distinguish between them. You cannot take one claim on its own and run away and say, oh, I understand the meaning. It's not possible. And this really hurt. This kind of argument will turn out to be the beginning of the end for the logical positivist movement. It destroys their theory of meaning. With the analytic synthetic, with the verificationism, boom, that's it. There's nothing left. Our ideas are connected like a web, he says. So some observations might affect our analytic beliefs as well. So again, the logical positivists want to keep those analytic things somewhere, right? And Carnap writes, no way that we observe something in the world and change 2 + 2 = 4. There's no way. That's absolutely unacceptable. Well, I can give you an example. Quantum mechanics has a huge influence on mathematical logic. We have created new logics, we have created new tools just to look at that and say, you know what, we need this, we need that, let's change this, let's change that. The observations in the beginning of the 20th century, I mean, that have to do with how to measure speed, how to measure time when you are at high speed, etc., etc. All those remarks, which are very physical, very observable thingies, etc., they had entailments on geometry. So now we needed a new geometry to look at, this Euclidean business doesn't really help anymore. And so to assume that you can run away with a claim and say this is analytic, and I understand the meaning of it, and then fix it in your theory, and then assume that no empirical data can touch this is wrong. And so directly, like the examples, or indirectly, because we are human beings, and we will see there's other things here that we are influenced by. These people were living in a war. They wanted to go to the US. They wanted to. We don't know what is it that pushed them to do this. It could be anything that they've seen, any experience. We cannot detach those from the theoretical body that we will love to, but there's no way really to tell what is it that influenced, what kind of experience they had that influenced their perceptions so that they can posit this or that or whatever. This is the main idea of Quine. I think Quine deserves a room as well. I have a lot of note to self here. I will see how I will arrange these. But this is the main point here. So problem number 1 was the verification business, and problem number 2 was the analytic synthetic distinction. The other thing as well, nothing is working fine for these positivists at this point. The observational theoretical, if you remember, we divided the two. The first step was, let's divide the language between two separate camps. A camp that is theoretical only, and a camp that is observational. We can see it, we can touch it, we can feel it. And then Maurice Schlick said, oh, it's exactly what you touch with your hands. And then other people said, you know what, this doesn't really work. We work in labs these days. And so they kind of modified it to include every bit of physical data or empirical data you can gather. And they assumed it's fine. It's not. It also fails. And another big figure that I'm going to keep mentioning from now on, Hilary Putnam, also picks up on this and delivers this blow to the movement. He says both theoretical and observational parts of the theory are what he calls theory-laden. And I'm not sure if I've used the word before, probably as I answered some questions, not today, but I certainly have used the word theory-laden before. What does theory-ladenness mean? It means they depend on the theory. They are affected by theoretical presumptions. Both the observational and the theoretical parts of my theory, they both depend on presumptions in the theory. They are both, quote unquote, polluted by these. You cannot escape, as Quine pointed out, this interconnectedness of the claims. As you try to understand this, the other one pops up, the other one pops up. And so, since this theory is polluted by what we can access and what we can observe and what words we have, what things we can perceive accurately, what errors we have in our machines, all of that stuff, it will pollute exactly the theoretical part as it changes to accommodate for this, because we gave up on fixing the theoretical part. Nobody wants to do that. and the empirical part, of course, it changed. So now this theoretical observational distinction fails because both things are up for modification at any point. And more importantly, most observational reports in practice, again, you can play with the theory if you want to be, but in practice, if you are a scientist, can you really distinguish between making an observation and not using theoretical language and then using theoretical? As you make the observation in the lab, you're going to use the theoretical language that you have. Every time you write a number, you are using a theoretical, quote unquote, theoretical entity. What do you want to do? Ban people from using numbers now because it's not observational. Ban people from using the words energy and center of mass, and you cannot ban people. These words exist in the theory because they are useful. They help us predict, and they help us explain, and they help us describe the state of the affairs that is in front of us. We both want to serve empiria. No scientist wants to go back to do it the old-fashioned Aristotelian Platonist way. Nobody wants to give away empiria and sit down on their armchair and invent science. But at the same time, as we have the theoretical entities, they are there to help us. And saying that these theoretical entities either are fixed completely or are meaningless or whatever is not really doing anything for us. It hurts the scientific progress. And so he also continues, again, we need to have a bigger discussion about this, but then one cannot acquire scientific knowledge of observable facts aspect of nature. We cannot even access what is unobservable. So there's observable and there's theoretical. So theoretical cannot be observed. As a scientist, you should say whatever it is that I don't observe, I don't know, I can't access it. And by that criteria, I'm combining it with verificationism, it's meaningless. No, the theoretical thingy is useful. And Putnam creates, by these two main ideas, he creates the new theory that we kind of mentioned in the previous rooms also, the scientific realism belief. That, the entities in my theory, as John Moneycroft keeps repeating, those entities, space, time, etc., those things are there in the model, and I cannot distinguish those from the real world. I cannot say they are the real world, but at the same time, I cannot distinguish them. You ask me whether they really bend or not, I don't know is the answer. But the answer is also certainly not the logical positivist answer, which is, oh no, you're talking nonsense, give me empirical. What are you talking about empirical? We have invented entities so that they can help us explain. I don't really care as a scientist whether space-time really exists or not. This is not my job. My job is to tell you what will happen with everything you're trying to do. And so if I can do that by using space-time, or by using the word energy, by using the word electron, by using the word wave, by using the word field, good, that's great. We did exactly what's required, QED. The other option is avoid using all these terms and do nothing. So this ontological commitment for these is reborn. It's given a new spirit under this realization. Whereas the logical positivists want to destroy that ontological commitment at all. They don't want to deal with anything that is not observable according to them. And the beginning for that idea is like sensory observe. Like I need to catch it with my senses, like with my hands and ears and eyes. But again, we cannot really blame Maurice Schlick. He was on the forefront of that new idea. So this is what the best that they could come up with at the time. And then the final blow, which I'm not going to go into today, but then this realization also by second and third generation scientists and thinkers that the social political aspects of science, the fact that scientists are people, and those people have biases, they have desires, they have political opinions, they have agendas, they could be bought, they could be sold, they could be influenced, they could be financed, they could be dried out of their finances. So all of these things, they drive change in the scientific community much more urgently than the validity of an idea does. in the real world. So we would love that if that those external factors of the social and the psychological and the economic and the political, we'd love if they never participated. But in fact, they do very heavily participate. And so the names I'm going to throw kind of started that movement, and then it blew up to include the feminist perspective as well. So now we have something called feminism science, etc., etc. The main names here are Thomas Kuhn, Lakatos, Loudon, Feyerabend. Feyerabend also has a very particular idea. He believes that science is exactly a religion. So we're going to do that as well at some point. We're going to go into that to see whether science is really a religion or not. Paul Feyerabend certainly believes it is. I'm not going to say anything more about that. You get the main idea. The main idea is the realization that all that logical structure, logic is the only way that is reliable. Yes, of course. Okay, we accept. But do we really use it? Can it really prevent other forces from influencing the theory? No, it cannot. What we better do, instead of ignoring the problem and pushing it under the rug, what we better do is to understand that social structure of science and to try to improve it by implementing more and more checks and balances and so on, so that we don't allow these external forces to influence the scientific revolution. After all of this, of course, people evolve. Those logical positivists who started when they were 20, 30, 40, now they became 60, 70. So the ideas evolved. They tried to reply to these criticisms. On slide 19, they created something logical empiricism. And they didn't really call themselves that. This is a term that they used interchangeably before and after. But now the main outlook is that logical positivism is the movement born after World War I, and then its evolvement, its new shape, its transformation after World War II in UK and in the US is called now logical empiricism. It's the same people and their students, but as they evolve, we give them now a new name. Which is the name that is much more famous for the movement than logical positivist. As they abandoned more of these ideas, this version is kind of more attractive. Logical empiricism is much more attractive, as they try to answer for the fixes or for the criticisms they try to fix them. Fix number one, verificationism, which failed with Quine, it was replaced with holistic empiricist theory of meaning. So, as Quine said, you cannot take a claim and run away with it. Logical positivists said, you know what? Yes, that is the case. So we're going to replace it with a holistic empiricist meaning theory. The whole theory now has a meaning. They conceded. The whole theory needs to have an observable phenomena. Not necessarily every and each claim of it should be observable, not necessarily every object, but the whole entire theory should be describing something observational. If you cannot describe something observational, don't talk to me. You are not part of the scientific conversation. So, for example, they allowed for, and they should, electrons, center of gravity, energy field, all those words now, since they are used to describe actual observable thingies, they allowed them after they were banned, quote unquote, under the verificationist thesis. Analytic synthetic went through a lot of revision. I don't want to go into it. I did not find it useful at all. The notable one was Carnap's, as I mentioned a minute ago. Carnap used very sophisticated methods in logic to turn around the fact that Kurt Gödel, which also I promised you a long time ago that I will explain the proofs at some point. Kurt Gödel, very shortly, he proved that mathematics is either incomplete or inconsistent. Either we have contradictions within our systems, which we work carefully not to have, and then if we accept that we don't have them, then the other option is there are certain statements that are undecidable. You cannot tell whether they have a proof or not. You cannot find the proof, but you cannot find a proof of the negation as well. Or you can prove the thing and its negation. And so this took a hit, because if you are a logical positivist and logic is your main way of thinking, other than philosophy and all that, the other stuff that they rejected, then logic took a hit here. Logic took a massive hit. Carnap stepped in, and to fix logic, to fix analytic synthetic, he came up with very sophisticated ways to say, oh, I'm not going to talk about provable, I'm going to talk about, what was it, that the word that he used? Confirmation, I think. This is confirmationalable or something like that. And he defines it in a very clever way so that he circumvents the Gödel proof, so that a theory, the scientific logic, so the bit of logic that will be used in the scientific theory does not have the problem of either incompleteness or inconsistent. He fixed it by putting one more clever twist or one more clever condition. I really cannot talk about it because we haven't talked about Gödel thingy, so there's no point in going into it unless you have some of you have specific questions about it. But these are the main fixes that happened. And as you will see, even those did not help. On slide 20, not the last slide, but the last kind of episode here of the fixes. Theoretical entities were transitioning to become observable as experiments developed. This is what we did not pay attention to, neither than the logical positivist, neither the logical empiricist. They fell in that trap. They divided the language into observational and theoretical. And they started to fix it, with oh, we have the verification. Oh, we will fix. Oh, the holistic is fine with us, no problem. They conceded, but then what they did not pay attention to is that as science progresses and as we have more and more technical ability, what was theoretical before now is observational. We have theorized for the Higgs boson. Now we detect it. We have theorized for gravitational fields. Now we immediately detect gravitational waves. And so, what to do? What is this distinction? Even though you want to include it now in your new revised version, you want to kind of make it looser. No, the distinction itself doesn't make sense at all. Things transition between being observable and theoretical. Okay, hold up a second. This is useless. And the big mistake is that empiricists still held at that point that there is no depth in science. That was their main motivation. That was their main idea. There's no depth. There's no 1 level, 2 levels, 3 levels. There's no this, as Sam said in the comments, center of the web and then peripheries of the web, so different levels. No. Science is so flat. Science is so accessible. It's the simplest thing you can do. And of course, this was not a very lucky formulation, and they were not successful. Staying in that camp and then watching the huge development of physics from the 40s, the 30s, 40s until the 70s, huge development. Watching this, they could not evolve as fast. It was the end for that program. Of course, the holistic argument of Quine, as it started being formulated in the 1940s, it became much more powerful. And of course, other political and social interferences affected as well. Mainly after the move to the US, they had to become a little bit more moderate. Hans Reichenbach himself and his students, there is some rumor, and I haven't checked, but it kind of makes that every philosopher of science in the US can trace themselves to either Hans Reichenbach and his student, either him personally or you can trace your lineage back. So they were very influential, but at the same time, to earn that is to diffuse your how to express this. You cannot be so uptight as you evolve. You will not be attractive and you will lose. And they were trying, these logical positivists, to keep the spirit going, but they were not successful because they could not give up everything. And the clear problem was everything needs to be given up for a new understanding. Observational theoretical doesn't work. Verificationism doesn't work. It just doesn't work. You cannot keep fixing it forever.
So Shamash,
Yes.
one of my favorite examples, I think, maybe you'll agree, maybe you won't, of the transition from theoretical to observational is the shape of the Earth, which was a theoretical thing until very recently. Right, the shape of the Earth being a globe was a purely theoretical thing until very recently, when it transitioned
and then it became observable
from that to being an observational fact. Yeah.
Absolutely. I just pulled a fact. I love how you do it, John.
The flat earthers love it too. A directly observed fact.
I like your version better. So yeah, absolutely. So going to space wasn't even a thing, that we were working on until the Cold War really started, and until the space race started, etc., etc. And so nobody could have predicted in the 1930s that we are really going to do it. Of course, everybody knew that it was possible, but they didn't really know how, why, with what rockets. We needed to have the V2 rocket of the World War II and then work on it, and etc. So these things, they happened very, very quickly. And if the shape of the Earth is the thing, that it has to be the most obvious example. I totally agree with you. It's now observable fact. It was the theoretical bit. So I mean, you could imagine the shape of the Earth. You can make the claim that this shape, if we went to space, it is observable as a sphere. So it kind of falls under the fixes. Not the original view, but kind of one of the fixes that, oh no, it's not the directly thingy that you touch with your hands. It's something that you can possibly detect with some experiment. I don't know if you can defend that, but absolutely, we have even better. We have video now, which again was completely unimaginable in the 1920s. What do you mean a video camera? This is high HD with sound, from the moon, live feed. Yeah, okay. That's not something they could have seen coming. And that's what I meant when I saw they couldn't evolve fast enough as these changes happened. As Wissam pointed out also a minute ago in commenting on Quine, on slide 21, you see that there are more evolved visions of theory of how scientific meaning is created. Observational theoretical two camps doesn't really work. Here you have Fiegel, for example, in the 1970s. He has his version of how is it that the different levels of the web, let's call them, okay? So you have the observational, direct experience. You have empirical conception of those, because there is no such thing as only empirical data like that. When you transform it to data, you have interfered with tools in your theory, and that's a different step. When you say the state of affairs in the world, that the meter has a 3 on it, and me saying the meter has 3 on it is already a step. I'm expressing it, I'm translating that reality into a language device that is influenced by the entire theory. If you recall the term we used, theory laden with Putnam. And so this is the second step. A third step is that the concept that we've defined, they don't have to be observational, all of them. Some of them could be completely theoretical. And then you have primitive concepts. And then you have postulates above, or what we would like to call axioms, or you can have different levels of these. And you can go even the other way around. So you can say, oh, I can totally observe a pen, but then the microbes that are on the surface of this pen are harder to observe. You just need a nice microscope. You can see them. What you cannot really see with a nice microscope is, let's say, a virus that lives in this microbe or in this bacteria. And so you're going to need a bigger microscope, or an electronic microscope for that matter. And if you want to really see, you're going to have to power up that electronic microscope. And if you really want to interact with individual molecules or atoms, which is very difficult and very blurry, the deeper you go in these levels, the harder the observation, quote unquote, will be. Of course, we can observe a cup of water, but going down there with the details, zooming in, we still believe that these things are real, because the water is real and that the water is made of these things. But then we cannot really directly observe them. So there are layers of how accurately and how well can you observe even the physical things that are directly in front of you. So all of this theoretical theoretical observational thing, it collapsed, and this was the end of the movement. On slide 22, I have teasers for the next rooms. I have to talk about Bridgman operationalism, Karl Popper, Bayesian probability. As I said, Wittgenstein, Lakatos, Kuhn, all of these people, we will be seeing them in succession as they try to pick up on this momentum to try to come up with a new theory or new philosophy of science, as this logical positivist movement came to an end in the 1960s. People, even members of the logical positivism school, started writing, this is the end of the movement. Nobody is really talking about logical empiricism. I'll see if I can find a quote by Ayer I'll read you the quote verbatim as he laments the end of logical positivism, kind of the last breath or the last poem as they go away. But yeah, this is the end of today's presentation. This was logical positivism. We picked up on a previous room as it told the story before the 20th century, what was happening in philosophy with Kant and with Hegel, with Hume, all these influential figures. And today we covered this fast revolution between the 1900s after the Einsteinian revolution. And we keep bringing it up. This is, as John pointed out, this is a huge deal back then. All of this philosophical movement was influenced. All these people grew up studying Einstein in school, and it was the main model, the main motivation, the main example that they used to say, oh, look how wonderful science is, look how easy the flow of information, and how wonderful it is to change from one paradigm to the next. Whereas, all these other philosophies of idealism and spiritualism, they stay fixed because there's nothing empirical that will cause them to change. That was the main motivation of that movement. And as they tried to understand it, they failed as a first attempt, and then as a second attempt under logical empiricism, what people call, and they couldn't pick up the fast evolvement of, or evolution, I want to say, of all those discoveries that were being made very, very quickly, especially in quantum field physics, quantum electrodynamics. You cannot really account for all of those beings when you are using very hard language and very tight criteria as the verificationalist or the theoretical observation. Thank you so much. This is the end of my presentation for today. The floor, as usual, is open for more questions about this or about anything else if you feel like it. Thank you.
So Shamash, I have a question. When I listen to all of the kind of gnashing of teeth and changing minds about how this and that works, etc., I'm left always coming back to the fact that I don't think that any of this has had an impact, a measurable impact, certainly, and I wonder if any impact on scientists actually doing science. And when I think about science, I actually think, well, I think about physics. I'll just limit my remarks to physics. I think that in a reason, it's reasonable to say that physics was born with Isaac Newton. Now there were precursors. There were certainly people doing things that looked a little like what Newton was doing, but nobody had really done what Newton did in physics before Newton, which is to say, take a couple of just foundational ideas and say, these ideas tell us everything about the universe. I mean, they're to the extent that that they're applicable to things. These are universal laws from which we can understand everything in the universe. Nobody had done anything like that before. And we've come one step from there, right? There was Newton, and then there was Einstein. That's really it in the at least the gravitation mechanical domain. And then you can probably add Maxwell, electricity and magnetism kinds of ideas, although that's kind of sits in some kind of never world. There's a thing there too, and then there's quantum mechanics, etc. But I think that if you wind your clock back to what Newton did and just ask how has science worked ever since, I think it's just done what science always does, regardless of the justification you might make this way or that way, whether it's logical positivism or empiricism or anything else. Science just does what it does, and I don't think it has ever changed as a result of thinking deeply about the kind of meta ideas that philosophy does. It's not to say that I don't find the philosophy of science interesting. I find it really interesting, but I think it has no effect on what scientists do or how science is done. What do you think about that?
I disagree. And as you do your exercise of reviewing the 20th century or before 20th century physics, which is wonderful, as you say, pay attention as you're doing that. Pay attention to the introductions and the remarks that these physicists are making inside their books and in their writings, and then compare those to Isaac Newton's style of writing, and then compare those to modern publication. I highly doubt that you will come to me 2 months from now and say, oh, of course, Isaac Newton published quasi the same thing as we publish today. There's no way. There's a huge difference between the attitude that Isaac Newton had and between the attitude that you have today as you review a paper. Totally different. The language you will use, the objective, your role as a scientist. As we said with the logical positivists, it was a new idea that the role of the scientist is nothing but to describe. Isaac Newton wasn't describing, although he did, but he did way more. If you read his text, Isaac Newton did not see himself as someone who's just describing. Isaac Newton saw himself as someone unlocking the mysteries of the universe, talking to God himself. Now you tell me, oh, this is not, it has nothing to do with the science bit. This is Isaac Newton as a person, and then his science was. I agree, but this is what science was at the time. He understood all of that, and the people reading him understood all of that to be science. Today we have different conceptions, and so you look at that and say, oh, because Isaac Newton was a great thinker, Isaac Newton couldn't have spent all his life looking for hidden messages in the Bible thinking this was exactly science, but he did. And so the fact that the philosophical belief has changed, it has so much influenced today, the way scientists perceive themselves and perceive their work today. The thing that you can immediately detect, other than the publications, is that today, if you go for opinions on science, it is very limited to the people who have really studied that science. Who are the stars in philosophy of science today? And I'm not talking about the people in the literature. I'm talking about the people on TV. Neil deGrasse Tyson, Bill Nye, Brian Greene, right? All these people are very well educated. They really studied the thing. They were really in the lab, and then they are allowed to say their opinion. This is a direct result of the logical positivist movement. Before the logical positivism, people were giving their opinions on science and mathematics without actually studying it. Immanuel Kant was not a mathematician, although he was a very clever person. He just wasn't a mathematician. Neither was Pascal, neither was, well, Descartes was, but to some extent. All these people gave themselves the freedom to go and make claims about math and physics, although they did not know exactly what they were talking about. Partly, huge partly, because back then it wasn't very much formulated what the role of science was. And it wasn't given the authority, the same authority that we have for science today, as this neutral method of establishing common truth for everybody. And not an activity that is, confined to the Royal Academy of Science in a closed room among 15 people, or among debates between people who write each other, riddles. Isaac Newton answered the riddle of Bernoulli, and now he is Isaac Newton, and Bernoulli is Bernoulli. We don't do that anymore. I'm not sure if this answers the core of your question. Of course, what is discovering the empirical facts of the world is still part of science, but all those extra parts were removed as a direct result of this movement. At least that's how I see it. If you look at the history again between the publications before and after, you will see the difference very clear.
Well, I find this would be a very hard thing to do, but I try to imagine how science would be any different today than it is if there was no such thing as philosophy. I mean, is there a kind of an obvious thing you would point to
What's
that
the
might be
difference?
different?
Yeah, what's the difference
I
between
would say,
Newtonian mechanics and Einsteinian relativity? What's the main difference? If you want to think and give me the main addition of Einstein, what was it?
Well, I wouldn't call it an addition, right? I mean, I think they're based on completely different foundations. The foundational idea is completely different in the two
Great, fantastic.
things.
What was it?
Well, in Newton, of course, it was the idea at its root, the idea that stuff attracts stuff. That
And
was the
you would
idea,
call
right?
that an empirical or a theoretical thing, or a scientific. It
Oh,
has nothing to do with the
well,
science. This is a purely philosophical issue. Are we ready to embrace the fact that there is a magical thing happening in the universe and stuff attracts other stuff? Are you magically ready to accept that the planet, as you come closer and closer to it, will pull you with a harder force depending on your distance, and the planet would know exactly what the distance is to calculate that attraction? That's exactly the motivation of Einstein to start thinking about, oh, there must be something else going on, something
well,
simpler.
well, no, I mean that. I mean that really wasn't the motivation, right? Einstein was motivated at first by thinking about light, and thinking about and maybe peripherally by odd experimental results in the 18th century about light. But in both cases, the theories, the foundational ideas of the theories are based on empirical observations, things things that we didn't understand. And in Newton's case, he said, well, what if stuff attracts stuff? And in particular, what if stuff attracts stuff in this particular way? And then augmented, of course, by what if then the forces of those attractions cause this specific kind of motion, a rate of change of velocity, et cetera. However you want to think of that. The important thing is the gravitation part. In Einstein's case, um, it really started with just thinking about light and ideas of space and time. And then it wasn't hard to understand that that had an effect ultimately on the thing that Newton himself was troubled by, this ridiculous idea that stuff could attract stuff across the vastness of space without and based on where they are right now, right? It had to be an instantaneous interaction between things at arbitrary distances. Newton thought that was a crazy idea, but he knew that it's hard. It had something going for it in the fact that it explained an apple falling from the tree in the same breath that it explained the moon going around the Earth. That was a pretty cool thing. Einstein did the same kind of thing, and I guess I'm at a loss to imagine that understanding, ideas of empiricism and analyticity or analysis and synthesis and all that would have changed. These are just people using math for sure, right? The math was at the heart of all of it, and that's an interesting topic. But I don't see how we would very likely be in a very different situation today if philosophy didn't exist. And once again, it's not to discount the the importance ultimately of unspoken. I think there's unspoken philosophy behind science. I think all scientists innately understand what it is they're doing, and probably have a philosophy about it, whether or not they've ever thought about it. But it kind of comes. It's like morals, right? It's just there. It's like there's an absolute morality or something. Science works the way it does for reasons that are both mysterious and just perfectly obvious. People who do science do it the same way, I think.
I don't know about people doing it the same way. From talking to people, if you want to involve people, and I'm not saying we should or we shouldn't, but if you want to involve scientists, personally, I find that what you're talking about is impossible to find. Finding that shared common method and belief among you will find two scientists working in the same exact lab who have totally different understanding of what is it that they're doing and why. Totally different. And the only thing keeping them together is this method that we have developed of I publish and other people check. So that, and they check blindly in most cases, so that there is no bias, there's no whatever. But then you can always make the argument, and I think you agree, that this is not foolproof. In fact, there's a lot of problems even with this. That's the only thing keeping the whole thing together. Other than that, you talk to the scientists and you grab them. Okay, why are you doing this? What is this? What does that mean? What does that entail? And they have no idea. That's why you find scientists talking on YouTube or on the media, with COVID thing, for example. Everybody has totally different opinions on what are the entailments and what is the role of science and what is it that. So the social aspect that you brought up is, I wholeheartedly disagree that this is common between people. I don't see it at all. All I see is differences. If there's 8 billion people on this planet, there's 8 billion and one philosophies of science. But to go back to your main point about how is it that it affects the building up of scientific theory. I was asking you about the Einsteinian revolution, and that's only one example. Imagine, okay, that we have lived in a parallel universe, where in this parallel universe, instead of having that attitude of, you know what, we can understand and these things are under our control and under our perception, the understanding, their belief was, which was for most cases of history, we cannot. Just imagine having that mentality. Just imagine having the mentality of time and space, as Kant proposes, are intuitions that can never be doubted. And imagine the young Einstein from his very infancy being told that time and space are intuitions and you can never question or doubt it. What will happen? You tell me, oh, but there are empirical things that start developing. We start having problems in our measurement of speed at high measurement of time at high speed, and how is it that we synchronize clocks and so on? And this made him think. Well, guess what? If this is it, Lorentz has the answer. That's why I ask you if you got to Lorentz or not. Lorentz has a perfectly classical understanding of everything that special relativity tells you. There's nothing extra in special relativity that other physicists did not know at the time. All you need to do is correct for some factors that Einstein called the gamma factor, with the special relativity, and now we teach it to students. Now it's very easy with Pythagoras theorem, as long as you assume that the speed of light is not affected. But you can do the math, the same math, in a totally different way, where the speed of light is affected by the vehicle carrying it, and you can add the speed and you can get speeds bigger than the speed of light, smaller, no problem. But then you say, but the empirical evidence disagrees with it. Then you change your empirical evidence.
Right.
The interpretation of this empirical evidence, again, is theory laden. Do you know what I mean?
Well,
I'm not sure if this does the job, but this is my last attempt for today.
Yeah, no, Lorentz's ideas would have been shown to be wrong because he didn't have time doing anything different. And time does do something different. So Lorentz had a really nice precursor idea, but his ideas were wrong. We know that, just as surely as we know that Newton's ideas were wrong. And in neither case is it to say there wasn't, a lot of beautiful truth, a lot of stuff that mapped onto reality pretty well, right? Lorentz was a brilliant guy. Certainly came up with a really good idea, an idea that's kind of mirrored in a funny way, in a funhouse kind of a way in Einstein's theory of relativity. But it was wrong, and we would have very quickly found out that it was wrong if we'd gone down that path.
I'm not sure what is it that the experience that you will do. I think Lorentz fails when you start including gravity and accelerations.
Well, time.
That's where he fails.
It doesn't treat time correctly, and therefore, and
it doesn't treat anything correctly. It doesn't even treat it. So time and the distance and speed, all of it. When you start fixing one of those, the whole thing collapses. So when you have time not working correctly, you have speed and distance not working correctly. So you end up with a totally different. But then the empirical entailments of this is exactly the same thing as Einstein's. What we chose as a species is follow Einstein because that idea is simpler and more attractive. And boy, did it deliver when general relativity was born. Then everybody raised their hands. Then everybody is like, okay, now we have something completely different. But if you limit yourself to special relativity, my point is not to debate relativity. My point is to use this as an example to show how is it that philosophical, what you called unspoken, maybe it exists unspoken, but it's dangerous to keep it unspoken. And so as these people were kind of speaking about it and using that development as an example, I think it really affected the attitudes of the following generation, Niels Bohr and Richard Feynman and those influential characters. they were born in that universe rather than the universe of let's stick to the classical framework, which would have, maybe I will give it to you that we would have changed eventually, but it could have caused us to be late 100 or 150 years or God knows how many.
Yeah, I mean, I think that there's clearly the difference in modern physics is that um, things are no longer intuitive. The beauty of Newton's laws, and in some sense, they really are an encapsulation of the intuitive. Everything about Newton's laws. I mean, I guess some people would say they're not intuitive, mass attracting mass, etc. Um, but all of that stuff is very intuitive, and what physics has, as it has matured as a science, we've just kind of learned that the fact is that the universe is not intuitive. We still do what we've always done, and that is to see what happens when we push this button, see what happens when we, lay this wire over here, connect it to a battery, push this switch. It's what we've always done. We're still doing exactly the same thing, but we find that the only explanations that work are explanations that now have entailments that are really not intuitive. I mean, even Newton's laws had non-intuitive entailments in terms of the possible kinds of orbits. You can get some kind of interesting orbits, et cetera, lots of kind of non-intuitive things, but they weren't things that made you think, oh, it can't be. But that's a matter of degree, right? It's just we've learned that the universe is less intuitive than we thought for a long time, and it's not surprising that um, early science developed along ways that didn't violate that intuition very much. But as we make more and more careful observations, there's no way out but to come up with theoretical models in exactly the same way I would argue that Newton did, that just that are forced on us by the observations one way or the other, and that just violate our intuitions in a lot of their entailments.
You are a solid logical empiricist, aren't you? That's
I,
what you've
I
discovered about yourself today.
I guess so. I thought I liked the logical positivist thing, but maybe you're right.
No, I'm just joking. But
But it's
I'll carry.
go
Yeah,
ahead. No,
go
go
ahead.
ahead.
Go ahead. I was just going to say that I will carry that debate about Einstein with you in private because I do have some papers to show you to see what you think because you really like relativity and to pick up the thingy. But if you agree on the statement that this verificationist business contradicts the holism, if you just agree on that, you cannot hold your belief that you just explained right now that it would have evolved in the same exact way. If you agree that the theory and our understanding, as the logical positivists or wanted to have it, but they just wanted to exclude most of other things. So they wanted to include only hard sciences as a domain of study to unify our understanding. If you agree that it's an entire web, and if you agree that meaning is built as an entire web, and everything that you want to understand depends on some very, let's say, central or existing without them being central, theoretical limitations or tools, let's say, what we call theory laden, then you cannot keep holding the belief that whatever we change in that space has no effect whatsoever on the scientific community in the lab. If you still hold that, then you are a very hard logical positivist, which has nothing wrong with that. I just showed what the movement believes and what the weaknesses are, and what this is a philosophical belief. And I'm not trying to shame at all. I'm just saying. Be aware that if you believed what I just said today, what you've just said kind of contradicts with it. And if you can find a fix, then you can totally publish it, because I'm not aware that there is a fix for these things.
Yeah, well, it's just interesting to me how I think the two, philosophy of science and science, kind of work in tandem. Um, And that's what Sam says in the chat. I do agree. I think more scientists should spend more time thinking about the philosophical matters. But I still, at the end of the day, I come down like I think so. I think you are. I think maybe you might be of the mind that with different philosophical underpinnings, or if scientists paid attention to something else, we might have that our theories might be kind of at the same level, same stage of advancement, however you measure that. I don't know how you measure that.
Not only,
But
just
but
say different. That's all I want. It would have been completely
but
different. That's what I
well, and
believe.
that's the point I wanted to say, that we could be at the same stage of development, having gone through a few hundred years and something, and have a completely different view of what reality is.
Absolutely. Yeah, I
Yeah.
do believe that another alien civilization, we will find a very hard time making ourselves understandable to them and vice versa. Even you remember we did this in one room when we talked about mathematics. Even Carl Sagan, when he wanted to think about it, he started doing these dashes and dots as ones and zeros. And this is our best attempt to kind of communicate, oh, this is what we understand of the universe. We cannot even fathom how the bees and the ants and the fish, how do they perceive the world, and what is the quote unquote scientific theory that they have. Of course it doesn't look like ours, it doesn't have calculus, but it works wonderfully well. And so to imagine what another species on another planet would discover, of course philosophical and linguistic and physical restrictions that we have in our bodies, the kind of colors we see, of course all of it defines most of what we can and cannot and the directions we go. Plus add above it what we discussed today as well, and we will discuss later on, all the social and political influences over the last 200 or 300 years. Massive influence today. Sorry, I want to go on a rant for 2 minutes. Academics, it's so sad, the state. It's exactly like begging, almost like beggars. Please, can you let us do this? Well, look, I'm such a good scientist. Can you give me funding? I'm going to do this and this and that. Can you please give me the $200,000 to give to my 10 students and 15 people who are doing? Please, we will include questions about sugar. Can you go to Coca-Cola and ask if Coca-Cola is interested about sugar consumption? We will put some questions in our studies so that will reflect on it, so that they can you please give us the money? All of this is completely hindering or pushing research programs above others. And so if you want to call this philosophy, you want to call this social science, you want to call this, I don't know, but I certainly know that the empirical facts and the study of empiria is not the most important thing on scientists' agendas at all. I do believe that their philosophical biases and how much aware they are of what they are doing and what are the details totally affects what they look for and what questions they ask. And if you really want to pay attention to it, pay attention when we have Sam, when we have Hansen on stage, when we have Benjamin. All these people have completely, I know because I talk to them, and I'm not mentioning people because I want to talk about them when they're not here, but because we have common friends, and I know that they have completely different outlooks on what they do. And you say, well, these completely different outlooks, they don't affect the work. I say you cannot tell, because what you see is the publication at the end of the day, and then you say, oh, this was published and this was not published, but that's all you can tell from where you
So let
sit.
me ask you this. I mean, it seems to me, so I'm trying to imagine a world which is the same world we live in, just inhabited by people who grew up with kind of different philosophies or came in different directions, somehow built on what other people did differently, and have an utterly different theory of the world. They don't use, maybe they don't use space and time. I don't know what else they use, but I mean, I can't really literally can't imagine, but they have a completely different theory. I imagine, I have a hard time imagining even that, frankly. But I get a glimpse of maybe what you're saying when you, I think there could be. Um, but I think you would agree, would you not, that one could, in the same sense that one can write a French English dictionary or something like that, one could translate from one to the other, because it is, after all, really the same world, the same phenomena, regardless of how they're described. If happen, right? If they build, if I give them a thing from my universe, a meter from my universe, and I tell them how to hook it up, etc., it will read the same thing. They will have a different description for why, might use completely different ideas about why, but but there should be able to be an English-French dictionary between our two views of the world, or do you not even think that would be the case?
I'm really happy you brought it up. This is exactly the golden nugget that after 25 or 30 rooms, I will stop and say, okay, this is all I know, guys. This is where I got. Because that translation problem, and I mentioned this to you a couple of times before, is the golden nugget really here. I don't think anybody knows what are the necessary and sufficient conditions to create translation between two systems. And it is very difficult to kind of start because, as you say, in principle, we'd love that thing exists, but it depends on a whole lot of things. I just want to ask you this question. I'm not going to go for an alien civilization. I'm not going to go for a different species. I'm not going to go for a different planet. I'm just going to stay on our planet with other human beings who speak the same language. Okay, I'm going to give you all that. But they are a flat earther. Can you create a book that translates everything you want to say into language that they will accept and agree to? And now you're going to tell me, oh, but agreeing is not the same as creating the translation. Well, who decides if the translation has meaning or not? The interlocutors. If they look at this and say, this doesn't make sense to me, then the translation has failed. If science has access to objective facts, objective necessarily means everybody agrees to them. And if you have a flat earther in front of you and using other systems of thinking, call them whatever it is that you want, they reach completely opposite conclusions. You can call them uneducated as much as you want. And I do agree, some of them, most of them, they lack basics in but at the same time, your question was not if they lack or not. Your question, can you create translation? And here, I doubt that you cannot in
Well,
that particular example.
so I mean, I do kind of want to rule out flat earthers. I want to talk only about people who have successful, who aren't just ignorant, who don't deny. I mean, to be a flat earther means really to deny pictures that we have of the earth, to deny just enormous numbers of directly observable facts, things that I claim would be directly observable facts, regardless of your view. You take a picture, you try to take a picture of Mount Everest from 300 miles away, you fail. Um, you are going to fail every time you do it in this universe. You may have different descriptions of why that's the case, uh, but but a flat earther will will deny that that's true. They will say, no, you can take a picture of Mount Everest from 300 miles away. Well, no, you can't. You don't get to. I'm not talking about people who deny facts. I'm talking about a civilization that has just as much respect for facts as a scientific civilization, let's say, that has just as much respect for directly observable facts as we do. And I know you can attack the idea of a directly observable fact, but I think of them as things like there's this device that we call a camera. We can give a camera to them. Um, uh, would you, for instance, claim that they would have a different view of what a picture is, that the camera, you can operate this camera and the picture that comes out doesn't represent what they see. They see something different from what that picture shows. Because see, I think that I think I have enough faith in objective reality that everybody's going to agree that you take this device, you point it at something, you click the shutter, and then you look at the developed picture. You say, "Wow, that's what I was looking at when I did that." I can't imagine looking at that result and saying, "No, that's not what I saw."
But
Is it that far down the rabbit hole?
I really cannot. I don't know. I cannot imagine it. I cannot imagine the situation where this is a meaningful conversation. Because again, how is it that you're creating meaning? You're kind of basing it on correspondence. That's what you're trying to do, right? And this is something we're going to talk about in the future. Correspondence theory of meaning. I look at this picture and I see this object. I look up and I see that object and I say, oh, this is a picture of that. And this is a very old, if you remember when Plato, we started with Platonism, right? This is a very old idea. This is, for us, this is very intuitive. But if I am imagining a different civilization, I don't know if you give them that machine, and then how is it that you're going to tell them, turn around and snap it at that object? If, for example, in their senses, they see a completely different object in front, they have a different visual cortex, they have a different brain, and you try pointing with your finger, pointing works for us because we evolved as hunters. I don't know what they will. Maybe they don't have fingers. They don't have arrows. We use arrows in airports and all the time because, oh, go there. We understand what an arrow is. I don't know where they evolved. And so, of course, I totally agree with you that whoever is on planet Earth who grabs a camera and takes a snapshot should, in principle, see the mountain that we are talking about. But for a different species, I really don't know. I certainly hope so. It would be nice if they are just like us, but they had color green. You know what I mean? But I think nature will very much surprise us if and when we discover our fellows in the universe. I think none of us will ever see it coming. It is something that is completely just change the chemical basis of your DNA, change anything, and then you'll get something completely. Can you talk to a fish? The fish evolved with you. Try to get a fish to take a picture. Try to get a monkey to forget about the fish. Try to get a monkey to understand that what they see in the mirror is themselves. It can be done, by the way, and there are tests around this, but it's very difficult to establish. And you can say, oh, but I don't. I need an intelligent being to define intelligence. Intelligence is what you have mutual understanding with, and you don't have
Yeah,
mutual
but I
understanding with people who deny science. You don't have mutual understanding with other species, and so it fails. You know what I mean? The translation I'm talking
well,
about, only the
but I mean,
translation.
in both cases, I mean, I think there are easy ways for me out. I mean, it is the case that I don't expect to be able to talk science with a fish, um, and it is the case that I don't expect to be able to talk science with a science denier. So those are not the kind of people I'm talking about. I'm talking about people who who do who do science, and I'm
So
convinced, for
someone
instance.
like me who doesn't really know a lot about relativity, who comes to you and
Yeah,
says, "Look, I know all the math, I know all the physics, I agree to all the premises, but just teach me something. Does this field how does it this 4D manifold manifest when water is dropping from the clouds when it's raining? How is it that these things are walking in a straight line? And then you throw the equations for me and you say, "Oh, look, I'm going to explain it to you, etc., etc." But this is very narrow. You're not really translating a lot here. I'm agreeing with you with everything. I'm a student of yours in this situation.
I guess the the what I need, it's kind of like what well, I mean, it's the same kind of what I really need, I guess, is an example, which I think we're not going to be able to come up with. That doesn't mean it doesn't exist. Of an advanced civilization that really does have just a completely different view of the universe that doesn't include, for instance, concepts like space and time, or uh, or charge. They that doesn't. I know they wouldn't use the word charge, but that the concepts of charges and electric fields and magnetic, all of that stuff, is just not seen that way. That gravitation, whatever gravitational effects, aren't even described in terms of space and time and motion, maybe. Maybe motion itself, maybe time itself isn't a thing. I think there are lots of people who've kind of thought about the possibility, beings that see the block universe, right, that don't evolve in time. They're just frozen in. You can make up these things, but maybe it is just my limited imagination. But it's certainly in our own case, I just have a really hard time believing that first of all, I have a hard time believing that there's really any path to the present that doesn't go through Newtonian gravitation, frankly. I mean, my reason for that is just that that is the simplest imaginable for me description that works pretty well. It works. The reason we will always use Newtonian mechanics is the same reason that I see there no path to the present that doesn't come through Newtonian mechanics, even though it's wrong.
Tell you what, I'm gonna look for, and I don't have examples in my head on the top of my head. I'm gonna look for examples in the history of science, and if I cannot find it, then I'm more than happy to create a toy theory just to try to prove my point. But this is gonna take time, so I'm willing here to give me until next week, and then we see what you
You're going to need more than till next week, Shamash.
Yeah. If I'm going to invent a new
grateful.
gravitational theory out of Newton, but the easier one would be if I can find something in the history. So the immediate one in my head is now Lagrangian mechanics or Hamiltonian mechanics. But I'm going to see if all the questions you have are going to be answered or not. Let me sleep on this and see if that answers your question or not. We have reached the point where I say goodbye to all of you. Thank you to Wissam in chat, all the friends, Dude Cool, everybody. I can't see you right now. I'm out of the program, but thank you so very much for being here. Bye.